Hello, everyone.
Amazing, amazing. So without further ado, I won't take up too much time. We are really happy today and really lucky to have Slava joining us again for yet another workshop. So without further ado, Slava, you can kick things off.
Yeah, thank you, Joanna. Thank you for the introduction. uh, yeah, let's start from probably introducing myself. My name is Slava. I'm working at Aurora Labs for the last, I guess, 7 or 8 months. I'm here at the developer relationship position. And mostly I'm working like different educational materials, especially our dev portal site. I will share it with you here in a chat so you can take a look and read more developer articles about Aurora and the ecosystem, learn more about the different ecosystem products which helps developers like indexers, RPC nodes, oracles, stuff like that. uh, I don't know. What can I say more? In the free time, I love doing like some theoretical physics, listen some metal music. Um, that's it. If you will have any kind of questions after the workshop, or maybe, of course, during workshop, you can. If you have a question during the workshop, please let me know. Write directly to the chat. I will answer immediately or after a small pause. But if you have more questions after the workshop, you can always find me on the Aurora Discord. You can find it either at the aurora.dev site in the developers section, or let me just share the link with you also. Yeah, or here. Yeah, so you can go to the Discord server, go to dev support, and you'll find me there. I'm pretty active on that server, so I will be able to address any kind of questions after the workshop. Okay, let me just ask the participants one simple question. Like, overall, please maybe write to me a little bit in the chat. What is your experience with Aurora and Solidity development? So I will be know more about like on which points to focus during the workshop more, and which should I skip, and maybe just talk about philosophy, and our products like Aurora Cloud. Yeah, while you're answering, probably I can start by showing you what Aurora Cloud is. Let's start with this. You can write meanwhile to the chat and listen to me. It will be like a pretty easy information. Let me share my screen. Probably I will share everything right away. Oh, great to hear, Fernando. Great to hear. Yeah, if you compare developing in Aurora to developing any other Solidity contracts, there won't be a big difference. So overall, it's kind of the same. And like 99% of the code you wrote should work, if not 100. I'm not sure. Like I never seen anything yet which doesn't work. And if something doesn't work, usually it's not in the contract itself, but on the side of NEAR or Aurora contract. But usually everything works smoothly. So it just boils down to the changing your hard hat config, but we will come to this in a moment while taking a look at the code. So we will talk today about ERC-6551 proposal, non-fungible token-bound accounts. And also we will try to think about those a little bit in terms of the Aurora Cloud stack and how we can connect those, or maybe to have the interplay in between. So let me start with Aurora Cloud first, because it will be easier for me. I'm more familiar with Aurora products than with that Ethereum standard. So Aurora Cloud is a pack of products to make the blockchain easier to use for everyone. And by everyone, I mean the real users and businesses. So, and real users, by this category, we also mean Web2 users, people who do not know much about Web3. That's why the onboarding should be pretty easy for them. they shouldn't be worried about like creating the passphrase, writing down all of those like words for their private key. Like they just need to use the product and do not worry about the details. That's the scene. And for such people, we have what we call Aurora Pass. The release will happen really soon. You can learn more here on the Aurora Cloud dev site. And subscribe to the Aurora Pass release here. Just leave your email and click notify me. We will. So Aurora Pass is a dev wallet dedicated specially for using Aurora. And like the main aim is to onboard Web2 users and big Web2 companies to use this to integrate into their solution while using other two products inside the Aurora Cloud. So Aurora Cloud is like a box or kind of proposition containing three products. Aurora Pass is for users, and we have also two propositions for companies. One is called Aurora Silos, and another one is called Borealis Business. So Aurora Silo is just a dedicated blockchain. So it's a way to basically create your own Aurora with the help of the Aurora Labs team, our developers team. And Aurora Silo is a whole blockchain, whole dedicated blockchain, the same way like the Aurora is. Specifically tailored for the company needs and product. It could be public, it could be private, it could have KYC, stuff like that. So it depends on your use case. Like we already have a few real-world products using that. One is the energy company. I guess the name is Empower, and the another one is a real estate agency called Nebocry. They working on like a modular designed homes or something. I mean, the idea is to make kind of like identification between NFT and home, and by having like a dedicated silo to incorporate the whole like business of doing real estate, like sales and buys inside that blockchain. Like I'm not sure about the details, but it should be really cool because people will be like, first of all, investors, you will be able to invest there. So it's like a private ecosystem for investors to invest into that project. But also it's a system where users will be able to exchange homes. And for example, user will be able to change their real location, but get the same home in another. For example, if you live like in Portugal and you want to move to, I don't know, France, there could be a home in France in Nebocry, the same home, and you can just like by doing the transaction on blockchain, kind of sign a contract that you will move to another home and will switch your location, but the home will be the same for you in terms of the design and stuff, like internal stuff inside the home. So it sounds pretty cool. I won't stop much longer onto this. Yeah, and we have like a middle player in Aurora Cloud stack called Borealis Business. And Borealis Business is the way for the businesses to obtain free transactions, like the big packs of free transactions per month. It's kind of like a subscription-based stuff. And technically, it's realized using the rule engine. And rule engine is like kind of a subsystem of our infrastructure, which looks and monitors over every transaction, filter the transactions dedicated to like some exact Borealis business deal, and then apply some cost transfers. So what it means that users of the company who owns the Borealis business deal will obtain free transactions because company will pay for those. So all of the gas will be paid by company. And the main idea of this is to free users from paying the gas and free users from thinking about why they should have paid some fees and stuff like that. So they shouldn't like think more about Web3. They just should do their business using Aurora Pass, and that's it. I mean, that's the basic idea. So overall, to sum up, Aurora Cloud is mostly business-oriented product, like B2B, and a lot of clients are asking us, like, could you provide more documentation about how to develop your own silo, for example, or stuff like that. But the reason, like, we do not provide or do not have much documentation is that because we are not expecting for people to use those stuff by themselves. We are expecting us to help them. And by them, I mean like some big or middle-sized businesses to create the product they want by the hands of the Aurora Labs company. And we just want to share our expertise, and we are selling these. On the side of the developers, they can integrate some stuff. For example, if you'll go to the developer portal documentation ecosystem tools, you'll already see like 2 posts about Silo and Aurora Pass. So in Silo, you'll see on what you can impact there as a client, but as the developer, you kind of cannot do anything because Aurora Labs will provide the contract for you and will program everything for you. So that's like not the developer part on which we can impact. But on the Aurora Pass side, every developer inside the company can create the integration with Aurora Pass. So, and for that, they will need to use Wallet Connect. And that's the way in which regular developers can use and be tangent to the Aurora Cloud line of products. For example, by integrating the Aurora Pass using Wallet Connect, or I haven't yet finished the article, but there should be an article about Borealis business. We already have one here in the dev feed, so you can read more about how does it work at all, how the deals are set, how the rule engine works. But overall, the developers also will need to integrate Borealis Business API on their site to whitelist people's accounts, stuff like that. So to sum up, developers have only 2 points of contact with Aurora Cloud. It is Borealis Business API and Aurora Pass Wallet Connect pop-up. And that's it. So it isn't much, but it's still like has some tangent points, Okay, maybe any questions about Aurora Cloud, because I will stop for a moment and we'll switch to the real code now. Let me know. I just want to go and to take some water because talking much takes a lot of powers for me. Let me just fill my glass. One moment.
No worries, no worries. Of course, anyone, if you have any questions, please do pop them into the chat. We'd love to hear them. If not, we're very excited for the code bit. But yeah, of course, any questions, do pop them in.
Yeah, so like overall, it's kind of hard to tie up Aurora Cloud with the regular Solidity development or smart contracts development work we are doing at the daily work as blockchain developers, because almost, I don't know, like 95% of work will be done inside the company in Aurora Labs, and will be just outsourced away for the clients. Okay, let me share the screen back, and let's go and see with what we will work today. So the idea, like actually for me, it was unexpected that I will do the workshop today a bit. So we kind of switch with my colleague today, and I will be reading his code and trying to explain what he has done there. So we will take a look at the ERC-6551 gift card repository and standard. So first of all, what is this? It is called like non-fungible token or NFT bound accounts. And the main idea behind it is just a possibility to add the wallets to your NFTs. That's kind of that. So the most simple example of it could be, for example, something in a game, like some person in a game, a personage or role, I mean, some hero who has the wallet and can gather some coins inside that. Or it could be a credit card, for example, right? So credit card really is an NFT with a wallet because it is tied to your bank account. So it's kind of like that. It just adds a possibility for the owner of the ERC-721 token to use the wallet and contract calling ability, so to control another account. And by changing like the ownership of the ERC-721 token, you will change the ownership of that account. So basically, if you will give your credit card to your brother or sister or mother, then they will own it and will be able to access your account, your bank account using that credit card, right? So that's the main idea, to like extend the NFT functionality and allow NFTs to control some like wallet-like functionality. So how it works in simpler terms, it has registry, which serves as a one-stop shop for creating new token-bound accounts. As we will see soon, token-bound accounts, those are exactly like individual wallets for each NFT. So they are owned by a single NFT, allowing the NFT to interact with the Ethereum blockchain, record transaction history on other on-chain assets like Ether or other token. So that account can own anything overall, but the control over it will be only in the hands of the token owner. Yeah, and the ownership of that token-bound account is tied to the ownership of the NFT. And this means that if you own the NFT, you also control the associated token-bound account. Probably I will just call it TBA today, just to shorten my speech. And compatibility was really big step here because previously Ethereum ecosystem had something similar, but previous proposals were requiring to change NFT contract, to change like NFT standards somehow, to modify ERC-721, so it wasn't compatible with the old tokens. But this one, it preserved the compatibility, so that's cool because you can reuse this like with any of the oldly minted tokens. Yeah, I will share this article. It's a good article about like describing why ERC-6551 is important and overall how it could be used in different games, different scenarios. We don't have much time today to read this. Let's jump straight into the standard. So let's take a look at this diagram. Overall, that's all we need to have in our head to understand how it works. So at the bottom here, we have user account. And this user account owns some NFT, this contract B here, which minted token number 656. So, and this token has a bounded account called account C, which was created by the registry, what's called registry. So there is a special contract called ERC-6551 registry. And it is creating TBAs, those bounded accounts. So you can see that, for example, one token can have few accounts actually here. And there are also what are called implementation proxies, but it kind of doesn't matter. Like the overall idea is that you can have like that account is kind of like an abstraction, and implementation is like the real one, the address and realization of that abstract contract there. So let's take a look at the code. And what do we have inside our hardhead? Yeah, so that's my IDE. I hope everything is clear for you and the scale is good. Please let me know in the chat. I will take a look in a few minutes there. Maybe I should zoom in a little bit. Let's start with hardhead config, I guess. So I will just instruct you how to develop on the Aurora overall. So let's start with the networks. So usually what I'm doing in a hardhead, I'm using two environment variables. First one is Aurora plus key, and second one is Aurora private key. So private key is just our wallet or address private key. So nothing fancy about this, right? It's done in the same way on any other network. But what is special, we have the Aurora plus key here, and I guess that after the Aurora Plus will be released, you won't need that. But right now, we have what is called Aurora Plus product. And inside Aurora Plus, we have a special API key. I won't show it to you right now, but you can find it here in Aurora Plus network endpoint. You can go to Aurora Plus site, register there. And by having that API key, you will obtain 50 free transactions per month. So you will be able to basically develop for free in Aurora without needing any kind of Ether. And even don't spend the Ether on the testnet, because you can use the same API key on the testnet, and that's pretty cool. So that's exactly what I did here. And another non-obvious thing I wanted to mention is the setup of the contract verification. So first of all, you need to be sure that your hardhead version is at least, oh, sorry. Yeah, okay. Yeah, you need to be sure that your hardhead version is at least 2.0.15. You can check it like npx hardhead minus version. So I have, 2.16 or 2.15, not 0, okay. So 2.15.0 is the minimum viable version, because there we have added the correct metadata for the Aurora networks. But anyway, like you can still add this other scan portion with the API key, and that's the main point of concern of the users. Usually, they don't know how to get the API key because we don't have any on our Explorer. And if you don't have any, you can pass here anything. So it doesn't matter what you pass here, but you shouldn't pass the empty string. So that's the bug hardhead has right now. You just need to put something here and it will work. And put custom chains. And in custom chains, just repeat the same like network, like testnet, chain ID. That's like for Aurora testnet, right? This network. And you will need to include our Explorer links to the API. And that's it. So that's how the verification is set up. Okay, let's go to the contracts. So as you can see, we have 4 contracts here. We won't take a look at the gift card extended today because, I don't know, it's not so enlightening, I guess. And it's pretty hard because it kind of encapsulates a lot of stuff inside of it. So let's just skip the extended card. And take a look at what we have at another 3 contracts. So they will exactly map to the registry, account, and NFT. So our NFT is called gift card. This is a regular ERC-6551 with URI storage. And like it has a few methods here, like to mint, obtain next ID, gift it to someone, and that's it. On the gift card account side, we have methods to execute call, to obtain the token the account is associated with, and to obtain owner. And if you take a look at the execute call function, you will see that it contains require. So it checks if message sender equals to the owner, where owner is the actual owner of the NFT. So it checks this. And if that's true, it allows people like to execute the calls through the execute call method. Yeah, also it includes something called supports interface, but it doesn't matter right now. And also it could verify the signature of the people, like of a person who sent the transactions here. Let me take a quick look at the corresponding documentation here. So in documentation, you can find the reasons why the account have the different methods. For example, receive is used so the account can receive either and like obtain it and store. The execute call, it says by default, token bound accounts must allow the owner of ERC-6551 token, which own the account, to execute arbitrary calls using execute call. And token bound accounts may implement additional authorization mechanisms here. So if you want to have like more restrictions in your account, you can do this. And also token bound accounts may implement additional execution functions which grant execution permissions to other non-owner accounts. So the idea is that, for example, you can allow your friend to also have access to that account and own the funds there. Yeah, token just stores the token and chain ID information, stuff like that, owner and nonce. Okay, so that's kind of it. And this standard page also contains the similar code which is inside the repo. So if you, for example, take a look at the account implementation, you can see the similar require here in the execute call function. Yeah, something like that. I actually had a problem with this code today. I don't know why it isn't working. So I just kind of hard-coded that and returned the tuple by myself. I can show you. Let me find this one. Yeah, so I just commented that out. There is some problem with decoding the bytecode. Not sure. I just haven't had much time to debug, so I just put the right values like chain ID, the address of the NFT, and my token ID I've minted for myself. Yeah, so that's it in terms of the contracts. And let's go and see what tests do we have. So if we execute hard hat, before going to test, let me check the chat. Yes, Frankie, of course. Let me share them right away to the chat. I'm glad that everything is clear. Maybe someone has more questions. I mean, do you see clearly my screen? I just been worrying about the font size because I'm presenting from the laptop, but just let me know. I will monitor time to time the chat. Okay, so I've shared the code. I guess, Joanna, will we share with the participants the links after the workshop?
Yeah, all links will be shared in the Discord after this.
Great. Okay, let's continue. So let's continue with testing. So testing is done as it's done usually, just with some peaks, hard hat test. And if sorry, something went wrong a bit. Yeah, of course. Something went wrong about that because I have this here, and for test it should be this. Yeah, let me try once again. Yes, it shouldn't be pure. It should be view. Oh, yes. Okay. Yeah, because of my changes, the test fallen apart because I've hard-coded some values here, but I shouldn't have, at least for the test. Yeah, let's take a look at the gift card test and what we have there. So inside tests, we are doing some preparations here, just obtaining owner and two more addresses here. We obtain the contract factory for the NFTs and deploy it, and then mint the NFT to the first address, this address 1, and then just obtaining the token ID from the contract, which has been minted. After this, we are deploying gift card account of 6551 standard, and also the registry. And after that, what's happening, we are actually creating the account using the registry. So that implementation is created. We need to provide for the create account method the gift card account address we have deployed here. Let me check. Yeah, here in the line 21. Chain ID. In this case, it's like a local chain ID, but on the testnet, of course, we'll provide like the right testnet value. Gift card address. This is the address of your NFT contract. Token ID. This is the token ID of your NFT from the collection. Some sold for like cryptography stuff and randomization. And this is the call data, I guess. But it could be just 0 for our purposes. Yes, so after that, we are obtaining the transaction receipt and extracting the first argument from the first event there. And event is actually like events were filtered by the account created. So we just taken the account created event and the first argument from it. And we are expecting that after deploying, we won't receive the like 0 code, like the error code, and that everything will go fine. So we have 2 blocks for the test here. One block is for the account and another block for the gift card. I advise you to take a closer look later at those tests, because those tests, they will explain how to work with the 6551 accounts in details. Let's see what we have for the account test here. So the first test is about that account should create that we should create an account successfully with the right address. So after the account was created, we are predicting its address using this function inside the registry. And after that, we just check that it has the same address. Okay, that's kind of obvious. And another stuff, we just get the contract, and the contract is the gift card account contract. And the address is the deployed address we got. And we just expecting that the owner will be the same as we have assigned, right? So the owner of that account will be the owner of the NFT. And that's exactly what happens. And the most of the functionality here is encoded in the gift card test. So what it has here, it has initial balance, final balance, gift card account, that mock. So mock is just our deployed account stuff, our TBA, token bound account. And we also check in here the owner. We are getting the initial balance. And as you can see, we are checking the balance of the deployed account address. So we just using that contract to track the balance. And we expect that to be 0. That's exactly how it is right now. And after that, we are getting the owner and sending the transaction to the deployed account address. And we are trying to send 1 Ether there. And we are obtaining in the same way the balance of the same account. And now, after the transaction happened, we are checking if it has changed the balance. So we should expect the final balance to be equal to 1 Ether, and that's exactly what happens. And another thing, we should mint and gift a gift card. That's probably the most interesting case. Let's dig into it. So we have token URI here. We have amount of the ethers here, 1 Ether. And what we are doing here, we just minting the gift card, the NFT, with the value which equals to the amount. So we are just kind of creating a gift card NFT with 1 Ether value. We are obtaining the receipt. And after that, we are obtaining the token ID from that. And then we call, on the behalf of the address 1 user, the gift card contract. And we are setting approval for all here. Okay. And after that, we connect on the behalf of the first user. We are gifting this NFT to the user number 2. And we expect that the owner will be equal. Okay, so it's just like minting the gift card to someone else. And after that, probably because the approval was set here, like the second user will have the rights to like put the funds out of the account there, and he'll be able to use the attached stuff. Okay. Let me see the channel.
Yeah, we do have a question. Someone asks, how are they different from soulbound tokens?
Let me find, I'm not sure what is soulbound tokens. Let me take a look. So SBT, it seems no, there are not soulbound here. At least they're soulbound and they are solely owned by the players and cannot be sold or transferred to other players. So that's the first difference, which I can see. Like, I'm not aware about soulbound tokens, unfortunately. Like, I don't know much, but it seems that they are not transferable, and that's the problem. I mean, in our case, it's better to just give your giveaway card and like to make a gift, right? And with soulbound tokens, you won't be able to do that. So in this case, that's the problem. I don't know much details, so sorry, I can't answer like this question right now. If you will wonder more, you can go to the Discord server, open the question for me, and I will make a personalized inquiry for you. Just take a look deeper, okay? We just don't have much time right now. So yeah, if anyone has more questions, just write more to the chat. I will go further and continue. So let me uncomment this back, or probably just do this to be sure everything works. So like overall to deploy, it's like the similar stuff you usually do with the hard hat. You just run the deployment script written in the scripts directory here. So we have deploy gift card.js, and that deployment script is actually doing the deployment of 3 contracts, our NFT, in the same way it was done in the test, kind of. The gift card account and ERC-6551 registry account. So like I've already done that for you in the testnet. So we will go and take a look how the contracts work. But right now, let me try to deploy them to the testnet. I can show you my MetaMask balance. So it is 0.9078. and it won't change after the deployment. So deployment should pass, and I will have 0 gas payment. Nothing will change for me. Yeah, so the first contract is already deployed successfully. Let's wait a little bit more just to be sure that everything will happen as expected. Yeah, there is some strange behavior here with gift card account about which I wanted to talk a little bit. So first, for some reason, it didn't want to return the address here and gives me undefined. But if you go like to the Explorer, here it's my account. I can actually share it with you if you will want to take a look at the transactions I made during the workshop or while preparing. Yeah, so we see the last 3 transactions here, like during the last minute. You can see that I have had no fees. It's zeros everywhere. And if you will go to the gift card account, you see that everything went fine. Like it seems that it is success and confirmed, so everything is okay. Sorry, it's transactions. Let me go to the contract. Yeah, so we are inside the contract. It will already be verified. So if I click read contract, you will see that inside contract, I am the owner. That's my address. And actually, why I am the owner, it is because this token bounded account is bounded to this token and on this network. This network is chain ID of the Aurora testnet. This is the gift card NFT. And right now I have minted myself by using this transaction, the first token, token ID 1, GCA, so gift card account. Yeah, and if you take a look at this, I guess if I click here, no, anyway, I have it opened. Yeah, so you can find the NFT. That's the NFT I own. I just put some image here, and that's it. You can mint your NFT by just going to the right contract here. This is NFT contract, and use mint function. For example, I can use some other account like this testing one, and I can put 2 here like this. Let me find the link Boris used in the test. For example, this one. Maybe this is the same. Maybe he has something else. Let me try this one. Maybe it will be different picture. So we'll put here something like that. And for example, I can mint it with some value like 0001 ETH. Oh, yes, I forgot to change something. Yeah, I wanted to mint it from my account, but to another account. Let's do it like that. Yeah, so it says that for the gas fees, I will pay 0, but for the Ether, I will pay that 1 to power minus 4. So we just need to wait for the transaction confirmation. Let's wait a bit. I will check the chat meanwhile. Yeah, good morning, Kazon. Any questions? Maybe you wanted to ask something. Let me check meanwhile how the transaction. So transaction went fine. If you will go to the transaction, you will see that the token with ID 2 has been minted already. I guess if I click on 2, I will see it. Yeah, so you can see that it is also gift card, and it is token number 2 here. So 2 NFTs were minted for different addresses, and now here is like one owner, and this is the second owner. Okay. Okay, let me try, like, so as you can see, that's like some strange error here. Not sure why it returns undefined, but everything works. Maybe that part needs some debug. Let me try and do the same stuff for the mainnet. Will it work for the mainnet? I haven't tried yet. Like I just tried for the testnet before, but let's try live for the first time on the mainnet. Maybe mainnet will work as expected here and return the address correctly. No. So it seems that the problem is in the code then, or somewhere during the deployment. I don't know. Like need to ask people from other teams to debug this one. But anyway, everything works, so it doesn't matter much. And like that was the part with minting NFTs and balances. What else we have here? We have gift card account deployed. And this gift card account, as I have already shown you, is associated with my address. And my mine token, the first token ID is here. And to finish, you need to call the create account method on the ERC-6551 registry contract. So this is the registry you have deployed. And we need to go to the right contract. You will see only one method here, create account. You'll need to put implementation address here, which is exactly the contract you have here. So you just copy this address. You will need to put chain ID. We can copy it from the same metadata here. Token contract, that's our NFT contract. So we need to copy it from here and put it there. Token ID. We actually have second token ID, but this account is actually already owned by the first token ID, so we cannot use this, I guess. And we should use number 1 here. Salt is just some random number. Like usually you need to use something big here, but I will just like put something for myself. Yeah, without any kind of randomization, and 0x here, and we can click right. Yeah, so transaction was successful. If you go inside, we will see inside the logs, I guess. Yeah, we are seeing that we have called this account created. And the first argument here is this new address. So this is the address for the implementation. And sorry, probably let me just check if I'm right here. So in the tests, we have had similar stuff here. Let me find it. Yeah, so you have this event account created, and we went to the first one and took the first argument. Yeah, so that's the address, the account that has been created specifically for that. Oh yeah, and it has been verified already, so it just needed some time to bootstrap. And this is the proxy contract, but do not confuse it with the proxy pattern. So it's a lightweight proxy. Let me find some information here. So it says that it is ERC-1167 proxy. So it's not like the upgradable contract. It just exactly what it is. It's proxy. It just proxying the methods from the account contract to this one. Yeah, and that's like the overall, it's the whole process of deploying the contracts we have seen on that diagram. And that's kind of finishes the overall deployment to the network and the infrastructure of the 6551 standard. Let me see if we have more questions. Let me take a look. Sorry, can I disable? Yeah, I will disable screen sharing for a moment, and we'll concentrate more on the discussion and questions now. So Kezon is asking, is there a best practice way to design Aurora programs to be built so it can easily be ported to Silo Aurora block? We can deploy everything we have designed today to the silo right away. So there is no reason like to change anything. I mean, it's just the way you are developing for Ethereum. It is the same way you're developing for Aurora. And that's the same way you will be developing for Silo. So my answer would be you shouldn't change anything. There are no like best practices. But overall, you should consider one thing, like silos are built atop of the NEAR protocol. And because of that, they can cross-interact using cross-contract calls with NEAR. So you should put as much heavy loaded calculations made to the NEAR blockchain. Because on Aurora, it will be more expensive and it's not needed to be done there. So inside Silo, it's better to cross-contract call some NEAR contract. It will be cheaper, but that's like another level of dialogue, you know. It's not about the developing in Solidity, it's more about architecture and that stuff. Yes, of course, I guess we will share the recording of the session and you will be able to follow the step-by-step process and play with contracts afterwards. I will also share my account, so you'll be able to play with them right away in the Explorer.
Just to add on that, Frankie, sorry. Yeah, all the video recordings will be shared in the Discord channel. Yeah, it should be fairly soon after the workshop, but all of these are accessible also on YouTube. So yes, definitely.
Yeah, sorry, my water ended, so I need to refill a moment.
Yes, water breaks are definitely needed. But yes, anyone else, any questions before we wrap up this workshop? We just have the last few minutes. So of course, if you are keen to, of course, as Frankie said, to try this out step by step, now is a great time to ask any questions beforehand.
Yes, so, sorry, it was really fast, I guess. But like even myself, I only understand, like I understand parts of the setup. I do not understand yet like how to apply everything in real project, I guess. But to conclude, like after showing the stuff for you today, it just seems that you will have that token bound account and you will be able to operate using it by owning the NFT, and that's it. Like that's the main idea, and that's how like development in Hardhat is done and deployment is done, verifying, debugging the contracts through the Explorer. So overall, you will be able to create something like gift cards transferable to other people, create like game characters using some coins inside your game, stuff like that, using the exact 6551 standard. To sum up, I wanted to clarify about Aurora Cloud part. So let's now think a little bit more. Let me see some. I will finish with my replic, and I will go back to the question, Frankie. One moment. So I just wanted to say that, as I have said at the start, it's pretty hard to connect Aurora Cloud to this because Aurora Cloud is more like business-based. So the way we can put Aurora Cloud in the interplay with those token-bound accounts is actually at the domains where those token-bound accounts could be used. That's the first place I would think of. So for example, if you will use token-bound accounts for your credit cards, it could be a silo, which is actually some kind of a banking or finance service. If you put it into the gift cards, It could be like used inside a silo project concerning some store. I don't know like what they will sell, but anyway, maybe wine, maybe some gift cards with wine bottles or something. So that's the one part. And the other part is the free transactions we have for businesses using Borealis Business and Aurora Pass for the regular users. And for you as the developers, I guess, and also for users, I guess, too, like you can think about this standard as a gift card, right? And because of this, by having like a gasless transactions, you kind of can transfer tokens with transferring your NFTs right away. So like, I guess it's not very important for the standard itself, but it's a good stuff to have in your project, like the gasless transaction using the Aurora Pass or using Aurora Plus, as I have used it during the development, because you won't need to spend the Ether, you won't need faucets, and that's the point which like accelerates your development, testing phases, and stuff like that. Overall, you will need to be creative to like try to combine those things, but that's like a prospect for a new hackathon project or something like that. Let me now go back to the Frankie's question: how to add new asset contract under the created gift card 65. So the question, like, how to add the asset there? I guess you can just transfer. I mean, you can just use that contract address as the usual address. So you can make it the owner of the NFT, some other NFT, or you can just make it an owner of ERC-20. So you can just do the regular ERC-20 transfer to that address. But after that, you won't be able to like transfer from that address without owning the NFT. So every execute call done on that account will be checking if you are the NFT owner, and that will act as a filter. So on all other aspects, that's the regular account. So you can use it in a regular way as you are using accounts or wallets of your friends to transfer assets, and you will just transfer assets there. But after that, to get those back, you will need to be the owner of the NFT. So be careful, and also read more about some security measures. I mean, there is an interesting case where you can make the NFT owner in the original NFT and set it to the address of your token bound account. So it will create a recursive loop, and you won't be able to withdraw anything in the future, right? Because the account will go and see like, okay, if I'm the owner, like it has like some problematics there. I don't remember exactly, but you can read more. Let me share this link also here. The problem is perfectly described there. I just don't remember the details. We are going to have free access to Aurora Cloud. So Aurora Cloud is just a set of product, and in a kind of way, everyone will have the access because of the Aurora Pass. So Aurora Pass is actually realized as Borealis business deal, where customer is Aurora. So we will provide some functionality already, and actually Aurora is Aurora Cloud in some way, because Aurora isn't different from any other silo. And by working with Aurora, you kind of already working with Aurora Cloud and silos. So I may say that everyone will have the access. And for the different silos you will have in the future on the market, it depends on the companies who own the silos, right, on their policies. If they will want private, then sorry, no, you won't be able to access. But if it will be public, of course, no problem. And you will have the whole infrastructure on the new network, new protocol. So all silos will be interconnected, and you'll be able even to cross-communicate between those and create the value of that interconnectedness and stuff. Whew, yeah, thank you, everyone. I guess we're out of time already. Let's wrap up.
Amazing, amazing. Thank you so much, Slava. Of course, as the links have been shared in the chat, any questions, please do reach out to the team. We're more than happy, of course, to answer any questions. But yes, of course, as previously mentioned, all of this is recorded. All the links will be shared as well in our Discord channel. So if you haven't already, please do join. But thank you, everyone, for coming. And thank you again, Slava, for doing this incredible workshop. Amazing. As you said, innovation and trying out new things is always the way forward. But yeah, amazing. Thank you, everyone. I hope you all have a lovely day, morning, afternoon, or night, wherever you are in the world. But again, bye, everyone.
Yeah, thank you, everyone. We'll see you on the Discord if you'll have more questions and stuff. Please come and talk more with me. See you. Bye-bye. Bye.
Bye.